Okay, so let's get into this. Word problems. Now, all the word problems that you're going to find in the algebra book, and probably the ones I'm going to give you, are admittedly contrived. They're really not going to be things that you might encounter or so, but they do follow the form of what you generally encounter for math problems outside of class, right? You don't expect that you're going to end up in a job where your boss is going to give you, hey, solve this equation for me. Unless you're helping them with night school or something like that, that's not going to happen. Most of the problems that you get that are algebra or any kind of math problems present themselves in terms of natural language. So we construct these word problems to kind of model an approach to that. Now, especially in a business context, you usually need to do some things a little bit more than just come up with a number. Okay? Very often you need to show others how you arrived at that problem, at that solution. Another thing that people don't expect very much is that you end up solving the problem more than once. And what I mean by that is either some of the assumptions change, or somebody wants to see some slightly different circumstances, or if you're dealing with requests from like a customer or something like that, you might get similar requests. So you do want to lay it out so you can go back and not have to reinvent the wheel every single time. And then also, you want to be able to present your problem to people who really don't have a clue about what you're talking about, right? Once you graduate here, you're going to encounter people that are much more different than you are compared to your peers right now. What I mean to say is that all of you are roughly the same intelligence, right? You all have roughly the same kind of ambition. You are interested in things, you want to learn things, you want to do things that involve your intellect. When you get out in the real world, you're going to find that some people are way, way smarter than you are, and you wonder, is this even natural that they're that smart? But most of the time, you're going to find people who don't have a clue. And you're going to be the one who's perceived as the smarter one. And so one of the nice ways to kind of handle that is to have your work presented in such a way that somebody can read over without you nagging them, saying, don't you understand this? You're really kind of stupid. You don't ever want to get in that position. You want to kind of share your knowledge with others. And so if you show them your work, then you're showing people that you have a structured way of thinking, that you're not an unusual genius, that you're just somebody who is well educated and can solve the problems. So don't underestimate the value of having your work that can be seen like that. Okay, so let's go over the 5 steps, and there's 5 steps. The first thing you do is you gather your data and you make your model. And you see I forgot my R at the end of that first your. But anyway, let's go over a question, and I'll treat all these steps as we go through them with this one question. And this isn't maybe too unusual of a question. So you bought a sweater for $56. It was on sale for 30% off, but you didn't see anything in the on the tag or anywhere what the original price was. So how do we solve that? Now, you know that there's some multiplication involved with percents, and do you take 0.3 or you take 56 divided by 0.3, or you try and think of some way to calculate this. But if you go through the whole thought process of what is a discount, all that sort of stuff, you'll end up finding a systematic way of doing this that doesn't rely on you having remembered tricks or formulas or things of that sort. So the first thing we want to do is we want to make our model. And so this is just basically a verbal sketch of what's going on, right? If it's something like the problem that we had earlier on the homework, you draw a picture. If it's something that is just a table of data, maybe you write your table of data. You do something to organize your data and to give you a visual impression of what that is. Now, this is the way prices work. You take an original price, you take a discount off of it, and you get a discounted price. So then you think, well, that isn't the complete story because I have to calculate what the discount is. And so a discount is we take a certain discount rate times the original price. So if you're going to buy something that is perhaps $100 with a 30% discount, you're going to take off 30% of 100, which is $30, right? So we have this kind of secondary model, and then we say, okay, I don't want to deal with two formulas. I'm going to combine them all into one model, and this is the model that I'm going to use to solve this problem. So notice what I did was retain the first box, which was the original price. That second discount now, I'm putting in the discount rate times the original price. And so you subtract those two, and the difference there is the discounted price. Now, there's really no connection, not that much connection with your original problem. You're thinking about what's happening when you're buying a discounted item. What happened to the price? Well, you had an original price, they took off something for a discount, and then you get the discounted price. So that's step one. Yes?
All right, if we're finding the discounted price, why do you multiply times the original price?
Well, because when you have something that you want to discount, you don't know where the price is going to end up, right? You just know where you're starting from. And the starting point, they call that the base amount in the textbook. You take the base amount times the discount rate, and so you have the discount, the amount that is taken away from the original price.
Oh, I see, never mind.
Okay?
I just need to.
Yeah, now, some of these things we know, and some of the things we don't know, and this formula isn't an attempt to make a formula that'll directly give us our answer. This is just to show the relationship of the values that we may or may not know. So that was step two. Now, or step one. Let me go into step two, and what I'll do is I'm showing that model again so we have something to work against. And so here it is, just copied from the earlier slide. And so now what you want to do is you want to define the variables and state the values that you know. So you don't know the original price, so we're going to use the letter P for that. Now, you can use any letter you like. You can use X or N or any of those kinds of things, but I found generally that if you use a variable that reminds you of what that variable stands for, like here, P for price, that by the time you finish your problem, it'll be a little easier to understand what you actually calculated. Now the discount rate I set as R, but I really don't need it as R. All I need is the 30%. That's my discount. So remember, it's pretty rare that you actually calculate with percentages stated as percentages. You usually put them in decimals, right? So we have 0.3 is 30%. The discounted price we knew we paid 56 bucks. All right. So step two, all my variables. So I look at the boxes on top. The original price, yeah, that's P. The discount rate, that's going to be 0.3. The original price is P. The discounted price is 56. And so step three is I can write this as an equation now. Now the first one I could write as P minus R times P equals D, or just substitute in the values you already need. And so here's this P minus 0.3 P equals 56. That's not a formula that you would think of, at least I wouldn't think of this immediately when you saw the original problem. You bought something for 56 bucks that was discounted 30%. What's the original price? Well, that formula doesn't jump out, but you have a valid equation that shows the relationships. So there's step three. Okay, step four is we're going to take that equation and we're going to solve it, and then we're going to check it. Okay, so how do we solve one of these? This is a linear equation just like we've been dealing with in the homework. P minus 0.3P is 0.7P. I'm just collecting my terms, right? And the 56 is unchanged. I don't want a decimal number, so I multiply both sides by 10, and I get 7P equals 560. P equals 560 divided by 7. I can't do that in my head. I don't have a calculator, so I use long division. I get 7 divided by 560, I find is 80. And so P equals 80. All right, so I found P, the one and only variable that I had. And I can check it at this point. I'm going to stick it in my original equation. Well, if 80 minus 0.3 times 80 is 56, that means 80 minus 24 is 56, and we have 56 equals 56, so my math is good. Now, at this point, you're tempted to stop because you think you found the solution. And in your mind, you did find the solution. We did, but when somebody asks you a question like, what was the original price of that? You're not going to walk up to them and say to them, P equals 80. I mean, that's when you really convince them that you not only know more than they are, but that you're truly arrogant about it. Okay, so you want to answer them in nice, plain English. You know, answer them in the language that they spoke to you. And so step 5 is answer the question. All right, so the answer to the question is the sweater originally was priced at $80, right? There's no mystery about that. That's a direct answer to the original question. And so when you're doing this, keep in mind that you want to reread the question, okay? And you want to make sure your units are right. So when you reread the question, maybe what you did was you're solving for a length and a width and you have L and W. Maybe you solved for L, but the real question was W. By rereading the question, you'll know that the question was, what's the width, not the length? And so there's where your variables, having the letter that reminds you of what it stands for, you know, that will not connect with the question if it doesn't answer the question, so you can formulate your question to be in English. And then make sure your units are right. You have a choice of units very often. We could have done this in pennies. We could have, with dimension questions, you can do it in feet, inches, meters, centimeters, anything like that. And chances are you'll have some numbers that will be in different units, and so you have to convert everything to be the same unit. Did you have a question? No. Okay, just a stretch. All right. So to me, step 2 and step 5 are the 2 steps that I really, really, really value. All right. Everybody wants to do step 3 and 4 only, but 1 will set up 2, where we make our model, sets up our definitions. Our definitions will set up our equations. You solve the equations, then you answer the question. So on this last slide, what I did was I just said, okay, I'm not making a presentation. How would I solve this if I'm just doing it on a piece of paper? It would look like this. So I have my thought process about how I got to my model, the original, just very simple definition of what happens with a discount, how I calculated the discount, combining the 2 into one model, make my definitions. Now here I didn't make the rate a variable, I just said 0.3 is the discounted rate, 56 is the discounted price, and then I use those boxes that model to form my equation. And then I solve my equation, and I write my answer, and I'm done, you see? So it's not all that different than what you would write if you were just kind of doing this in your head informally, but it is definitely a systematic process where, you know, you can identify these 3 steps. 5 steps, I mean. Now, I'm not asking you to label your steps when you're solving problems, but I do want you to keep it in mind. And while I'm scoring your quizzes, tests, final, and all that, this is how I'm going to grade it. I'm going to look for 5 parts in there. Did you make a sketch or a model or collect and organize your information in some way? Step 2, make your definitions. I just don't want to see the equation start out, P minus 0.3P equals 56. My question is, what is P? You need to say what P is first. And then, of course, the plain language answer. And that's all there is to it. Okay? So those steps, my sense is that the most difficult step when you're doing this for the first time is coming up with that step 1, the model. Not making your equation, not jumping ahead, but just think, what's going on and how can I convey this? So I have a few questions. And so I'll write them on the board, and then you'll have some practice to do this. And that's what we'll be doing for the rest of the class here.